evaluating expressions by substitution. So if you have a highlighter, sometimes when we come across important definitions, and in your notes you'll notice that often when I write a definition I bold it, but if we highlight it as well, that way when you're studying your notes, you see that and go, oh, I should read this again because it looks important. And that's when we exchange a variable for a number that's given to you. So when we look at our first example, okay, it says if x is equal to -3, what's the value of 3x plus 5? So variables are used sometimes when we don't know a value, and then later we figure out that value or we're told that value, then we're able to find what it's equal to. So where the x was, again, I'll take out my highlighter here, where the x was, now that x is equal to -3, I replace the x with a -3. Everything else stayed the same. And I have a note here that we want to put brackets around the value when we put it in. That makes sure that we do the right operations. Okay? Because what does it mean here when you have 3 and then bracket -3? It means multiplication. Would you agree that when we were writing things out before that this meant multiplication? 3 times x. If you didn't write the brackets, if you went 3, -3 plus 5 and substituted the -3 for the x, can you see that that looks like subtracting and not multiplication? So if we don't have the brackets, we might do the wrong operation. So here, 3 times -3, that's -9. Then if you think about your number line, you're at -9 and you add 5, that would get you to -4. So here, if x is -2, so again, I'm going to highlight that. X is equal to -2. That means wherever you have an x, you're going to replace that x with a -2. And that process is called substitution. You're substituting the number in where the x value was. And the rest is just order of operation and BEDMAS. So if I had -2 squared minus 4 times -2 plus 9. How do we do -2 squared? -2 times -2 plus 4. Here we have to multiply. -4 times -2, you agree that that's +8? Negative times a negative is +8. And then we still have the plus 9. Now we're down to just adding. 4 plus 8, that's 12. 12 plus 9, 21. I like to circle my final answer when we have to do more than one step, because there's lots of work to be done. Then it's sometimes nice to say, hey, I'm finally done. This is my final answer. One more example to look at. This one, we've got a value for x, which I'm going to highlight in yellow. That means wherever there's an x, that's getting replaced by -1. And we have a value for y, which I'm going to highlight in green. Wherever we have a y, that's going to get replaced with -5. The rest is order of operations. You would do the -1 squared first, and you would get +1. That +1 gets multiplied by the 2. You see you would get 2. -5 times -5, plus 25. And then finally, 2 plus 25 is 27. Okay, 3 for you to try. Again, once you're done the first one, get me to check before you go on to the second one. Saw a really good job of substituting in the numbers in. Some people like to start by just putting the brackets in with blanks. Like it's 3 times x, I put a bracket there, minus y, and put a bracket there, and then put the numbers in. X is 3, y is negative 2. 3 times 3 is 9. Subtracting a negative is adding. Get 11 for the first one. Second one, switch to green. I'm going to put a bracket for the x plus bracket for the y, and it's getting squared. So everything else stays the same, except where the variable was, we're going to substitute 3 for x and negative 2 for y. 5 times 3, that's 15. Negative 2 squared is positive 4. 15 plus 4, 19. Finally, the last one, 3 plus bracket for the y, bracket for the x. Where the y is, I'm going to put a negative 2. Where the x is, I'm going to put a 3. Adding a negative is like subtracting. So we have 3 minus 2 minus 3. 3 minus 2 is 1. 1 minus 3 is negative 2. Did you know that adding and subtracting doesn't matter the order? Like 2 plus 5 is the same as 5 plus 2? And if you did 5 minus 3, you could have done minus 3 plus 5. That would be the same. The reason I point that out is because if I switch the order on this one, it actually makes it even easier. Because I have 3, and then if I did the minus 3 and then the minus 2, your math is even easier, because what's 3 minus 3? 0. Minus 2 would be minus 2. So sometimes, if we look at how the numbers are, a little bit of mental math, we can make it even easier for ourselves when figuring it out. All right, for our next example. In our next example, it says, some cases it's easier to simplify first before substituting. So what does it mean to simplify when we have a number out inside? This is where we distribute. The 3 would go to those. The negative 2 would go to each of those. You're going to get some like terms and combine your like terms. Then once it's simplified, then you can plug in the number 1. So this is what it would look like. If I distributed, I'm going to get 3x squareds, 3 times negative 4 minus 12x's, 3 times 2 plus 6, negative 2 times negative 2, negative 4x squareds, negative 2 times 5, negative 10x's, and negative 2 times negative 12 plus 12. We now have some like terms. We have a 3x squared and a minus 4x squared. We've got a negative 12x and a negative 10x and a plus 6 and a plus 12. So if we put our like terms together, 3 minus 4, negative x squared. And then negative 12 minus 10. Think of your number line. You're at negative 12. You minus 10. You're at negative 22 x's. And then finally 6 plus 12 plus 18. And now we can plug in our 1. So I'm going to go negative bracket squared minus 22 bracket plus 18. And instead of writing x, x is equal to 1. 1 squared is 1 times a negative is negative 1. So order of operations, you'd square first and then multiply by the negative. Minus 22 times 1, minus 22, plus 18. Think of your number line. You're at minus 1. You subtract 22. Where are you going to be at? Negative 23. And then you're going to add 18. On your number line, you're at negative 23. You add 18. You get to negative 5. You're adding. Because you have to think, right? Here's 0. Negative 23 would be here. And now we're going back. We're adding 18. That's going to be somewhere here. What number would that be? That number would be negative 5. Okay. So by simplifying first, we had less things to plug in and less mental math to do. But this one wouldn't be so bad. Bobby, do you know what 37 squared is in your head? Or would you need a calculator? 37 times 37. Anybody? Would this be one everybody needs a calculator?
Yes.
Good. All right. Here's your next question. It's non-calculator. Let x equal 37. And this is the question. You have to evaluate it without a calculator. 2 times x squared. So that's where that 37 squared comes in. Okay? Plus 3x. Oh, I'm going to actually have 4 times 37 squared. Oh, my goodness. Plus 3x. No, I'm going to even make it bigger. Plus 8x plus 1 minus 4 times 2x squared plus 2x plus 7. Yes, I am actually expecting you to do this without a calculator. Go. And you'll see why once you do it. But before you do it, it looks impossible. Because you don't know what 37 times 37 is. You ready, Logan? We would distribute, right? And after you distribute it, you'll get 8x squared plus 16x plus 2, and then minus 8x squared minus 16x minus 20 minus 28. Like terms. 8x squareds minus 8x squareds will give you no x squareds. 16x minus 16x will give you no x's. And you're just left with 2 minus 28, which on your number line ends up at minus 26. So when x is 37, it's equal to minus 26. When x is 37,824, it's still going to equal minus 26.